Hey folks, the second part of our sum and difference identities is tangent. So last time we did it with sine and cosine. Now we're going to find the sum and difference identity for tangent. Like I said, you don't need to memorize these. So I'm going to go to my unit circle right away. I'm going to put them on here. Let's see, I went with a red and then a purple. What about like an orange? How about bright orange? Orangey, orange, orange. Yeah. I don't like that. I'm going to go with, yeah, we can go with it. Yeah, okay. So I'm going to combine them again. So that means I'm going to have an alpha plus or minus beta. So when this is a plus, the top is a plus and the bottom is a minus. When this is a minus, the top is a minus and this is a plus. So I'm going to do that kind of plus minus trick and I'll talk you through it one more time. If you don't get what I'm doing with these plus minuses, just write them both out. Tangent of alpha plus or minus beta is equal to tangent of alpha. All right, so notice the top, when it's plus on the top and minus on the bottom. When it's minus on the top and plus on the bottom. So the top is the same as what it begins with, and the bottom switches. So if this is plus minus, this would be plus minus again, but tangent of beta over 1, and then it switches around. So it would be minus plus tangent of alpha times tangent of beta. So this is plus, that would be minus. If this is minus, this would be minus, and this would be plus. So that's because I don't feel like writing both of them out. If you don't like it, you got to write both of them out. Sorry. Okay, so evaluate 7 pi over 12. So this is, again, one of those scenarios where I want to pick something that reduces with 12. So I'm going to pick from these circled numbers, find a combination that makes 7 pi over 12. The only way to do it, I'm going to do this one by adding. The only way to do it by adding is 3 and 4. So I'm going to go with 3 and 4. All right, so what does that look like? So this is going to be equal to tangent of 3 pi over 12 plus 4 pi over 12, which equals, okay, now I'm going to reduce these, which is the whole point. Tangent of 3 pi over 12 becomes pi over 4. Tangent of 4 pi over 12 becomes pi over 3. The whole point was we wanted to find two angles that we could identify inside of our unit circle. So now I'm going to plug and chug. My alpha is pi over 4, my beta is pi over 3, and we're doing the plus formula. So that would be equal to tangent of alpha, so tangent of pi over 4. It's a plus, so it's still a plus on the top. Tangent of pi over 3 over 1, and then this switches around, tangent of alpha, tangent of beta. Now I have to figure out what tangent of pi over 4 is. So I'm going to draw my pi over 4 triangle. Right angle, reference angle. Then I'm going to draw my 60-degree triangle. Right angle, reference angle. So this is my pi over 4 triangle. This is my pi over 3 triangle. Let's fill in the sides. So this is root 2 over 2, root 2 over 2. Any negatives? No, forward and up. This is root 3 over 2. This is 1/2. Any negatives? Nope, forward and up. Now, I'm not done here because I want to evaluate the tangent of these. So you can do that one of two ways. You can go the long way of actually doing y divided by x, or opposite over adjacent, or you can remember that we actually added what tangent was to each one of our special right triangles. So tangent of a 45 ends up being 1. Tangent of a pi over 3 ends up being square root 3. Okay, so let's take those things and plug them, chug them back into our equation. So this equals tangent of pi over 4 is 1, plus tangent of pi over 3 is root 3, over 1 minus tangent of pi over 4 is 1 times root 3. So this one's pretty easy to clean up. 1 plus root 3 over, I have to do the multiply first, so 1 times root 3 is root 3. So I would get 1 subtract root 3. Nothing cancels here. It's kind of tempting the way that 1 and 1 line up and that root 3 and root 3 line up, but those do not cancel. Also, you might notice that we got a root on the bottom. I'm not going to worry about cleaning that up. You guys, this is the one time we're going to ignore the mathematical standard of cleaning up roots on the bottom, and we're just going to leave it. So this is the one time you guys get away with that for free. So I want you to pause. I want you to try to do this one on your own, but I want you to do it with a subtract. So you have to find a combination of subtract. Actually, figure out which two that you're going to use to subtract, and then unpause it. Okay, so hopefully you found the two that work. You could do 9. We were trying to build a 7. So we could do 9 minus 2, or we could do 10 minus 3. And the reason I said unpause, let's just all pick the same one. Let's do the 9 and the 2. So this is equal to the tangent of 9 pi over 12. Take away 2 pi over 12, which equals, and now pause again and try to finish this on your own. So that would be what? Tangent of both divisible by 3, so that's 3 pi over 4, minus both divisible by 2, so that's pi over 6. So now I can plug it into the formula. This is tangent of alpha minus tangent of beta over 1. Well, that was a minus, so this is a plus. Tangent of alpha times tangent of beta. Now I have to figure out what those triangles look like. So I'm going to sketch a 3 pi over 4 triangle. So that's 1, 2, 3 pi over 4. So my triangle is going to look like this. Right angle, reference angles of 45 degrees. And this was my 3 pi over 4 triangle. I'm going to draw a pi over 6 triangle. I don't need the unit circle for that one. I remember it. That's a 30 degree. So this is my pi over 6 triangle. Side lengths, this is a 45, so that's root 2 over 2, root 2 over 2. Any negatives? Yes. The x needs to be negative there. 30 would be 1/2 and root 3 over 2. Any negatives? No. Forward and up, so we're good to go there. Now remember, I don't actually care about those. I just care about the tangents of those. So the tangent of my 3 over, that's going to be a positive and a negative. So positive divided by a negative is still negative. And then the tangent of this one, tangent of the 30, that would give me the root on the bottom. So that's root 3 over 3. That's a pain. We're going to have to deal with that when we plug and chug. You'll see what I'm talking about in a second. So, all right. So tangent of 3 pi over 4, we got to be negative 1. Minus tangent of pi over 6, we got to be square root 3 over 3. Over 1 plus tangent of 3 pi over 4 is negative 1 times tangent of pi over 6 is root 3 over 3, not 3 over 2. Root 3 over 3. Okay, so how do we clean these up? From here, you're not allowed to have, I'm going to let you keep roots on the bottom, but we can't have roots inside of roots. My bad, let me try again. I'm going to let you have a root on the bottom. We can leave it like that, but what you can't do is leave a fraction within a fraction. This is really tough to clean up. You'd have to times by the conjugate, and you get an answer that actually doesn't look a whole heck of a lot better. This is easy to clean up with a multiply. So what I'm going to do is I'm going to multiply everything by 3. When I times by 3, I'm going to clear out the fractions. Now it's going to turn the 1s into 3s, but that's okay because it's a good trade considering we don't have any fractions. So 3 times negative 1 is negative 3. 3 times root 3 over 3, those 3's would cancel, and I'd just be left with negative root 3. Over 3 times 1 is 3. Now look, I'm going to multiply this first, and then I'm going to times it by 3. So that's going to make this negative times this positive is going to become a minus. And then I'm going to times by 3. Those 3 and root 3 is, sorry, that 3 over 3 is going to cancel, and I get a root 3 on the bottom. Now, it doesn't seem like this. It doesn't seem that this is true, but it actually is. These two things, these are equal. Now, you might say, no way. Well, I could prove it to you, assuming you believe that our calculator is accurate. 1 plus root 3 over 1 minus root 3, okay, versus negative 3 minus root 3 over 3 minus root 3. What did I do wrong? Ugh, sorry, I'll try again. 1 plus root 3 over 1 minus root 3. Negative 3 minus root 3 over 3 minus root 3. Same thing. Yes? Believe it? What about this? Is this still equal? Negative root 3 minus 3 over 3 minus root 3. Is that also equal? Yeah. I mean, everything still has the same sign. So answers to tangent are going to look a lot different, but they're actually the same thing. This also is equal. So depending on how you pick your breakdown, you're going to get answers that look a little bit different. So anyway, all right. So now we should be able to do sum and differences for tangent as well as sine and cosine from last time.